Polishetty, the Chief Customer Experience Officer at Orbit Shifters INC. We Orbit Shifters extend a sincere welcome to all of you for the second day of India's first student virtual AI conference. This event brings together expertise from the industry, academics, and learners. This is an excellent opportunity to discuss and exchange views on existing challenges, further development perspectives in artificial intelligence, as well as get acquainted with the latest case studies. Moving on to the particulars of the event, it's a great pleasure for me to introduce our esteemed guest keynote speaker today. William H. Bill Inmon is an American computer scientist recognized by many as the father of data science, data warehouse, He authored 57 books around data warehouse topics. Bill wrote the first column in magazine on data warehousing. He has written over 1,000 articles on data warehousing in journals and newsletters. He created the first fold outwall chart for data warehousing and conducted the first classes on data warehousing. In 2012, Inmon developed and made public technology known as textual disambiguation. Textual disambiguation applies context to raw text and reformats the raw text and context into a standard database format. Once raw text is passed through textual disambiguation, it can easily and efficiently be accessed and analyzed by standard business intelligence technology. So I welcome Bill Inmon to address the audience now.
Thank you, Narendra. I appreciate that. Let me try to get my computer up and running, and let's see if I can get this right. They're sharing my screen. Now if I can get to my presentation. You are going to have to tell me. Is this presentation coming through?
Yes, it is.
Okay, thank you so much. First off, it is a real honor and pleasure to be speaking with you today. I'm here in Denver, Colorado, and it's nighttime here, but I see from the windows that it's daytime there. So I really appreciate this opportunity to speak with you about my favorite topic. About 12 years ago, 13 years ago, I kind of departed from data warehouse to start to talk about some other things that were interesting to me. One day I sat down and I asked myself the question, in corporations have all of this textual information, but it isn't getting used. And I thought this is kind of strange because corporations are using the information that they have, but it's really not the majority of the information that they have. So let me take you through the life of the data scientist. Suppose you go to school. Suppose you study data scientist to be a data scientist. I think that's a very good thing to do. I really applaud you for doing that. But what is waiting for you as a data scientist? The first thing is you need to go to school and learn a lot of information. And what kind of information do you learn? You learn algorithms, statistics, pattern recognition, visualization. These are the kind of things that typically are taught in the organizations that teach people to be data scientists. And then one day you graduate and you're happy to have gotten through your studies. Your teachers are proud of you. Your parents are proud of you, and everybody's happy. But what do you find when you graduate? What you find is when you go out into the real world, when you start to look at using your skills as a data scientist, you find out that in reality, data is a big garbage dump. That the data that you typically are given are used when you are doing your work in school as a data scientist is carefully preserved, carefully vetted data, and that's what you need to learn. What you need to learn. But when you get out into the real world, you find out that data is a big mess, and so that unfortunately is reality. Let me tell you what a friend of mine once said. That's a data scientist. He said, "Bill, we go to school, we learn all of these things, and then when we get out into the real world, we spend 98% of our time working with data, and we spend 2% of our time being a data scientist." That when you get into the real world, the life of the data scientist, and I don't mean to discourage you. I think being a data scientist is a very good thing, and I encourage you to do that. However, reality is when you get into doing it for real, you're going to be more of a data garbage person than you are a trained data scientist. Now, that's the way it is today. So I want to give you a little bit different perspective on data, the data that's waiting for you in your corporation. Let's suppose we have in this red bar here all of the data in the corporation. So this is what passes through the corporation on a daily basis. When you look at this data, one way to look at it is that a certain portion of the data is what's called structured data, and another portion of the data is something that's called unstructured data. Now, what is structured data? Structured data is typically the data that comes from transaction processing. When somebody cashes a check, when somebody buys a book, when somebody goes to a movie, these all create very structured transactions that are captured and treated as such. But when you look at the real data in the corporation, the vast majority of the data in the corporation is not structured data. And it depends on the corporation, but in reality, only a small fraction of the data in the corporation is structured. And so what do you find in today's corporation? You find that 98% of corporations' decisions are being made on 10% or less of the data. Now, I don't know if this strikes you as being something that's really unusual, but this isn't right. Your intuition tells you that, wait a minute, the people that are dealing with the structured data stuff, and there's nothing wrong with structured data. There's, again, nothing wrong with it. It's just that if that's all you're using for decision-making purposes, you're missing a major opportunity in your corporation. So what you want to do is look over on the other side of the world of data, on the unstructured side. And you say, wait a minute, I would like to start to make decisions based on this unstructured data. Now, when you look at unstructured data, it turns out there's actually lots of different kinds of unstructured data. There's analog data, there's textual data, there's all kinds of unstructured data. But when it comes to textual data, you find that textual data is very rich in business value, that there's a lot of really valuable information in text that the world is not looking at today. And so the inclination is, gee, Bill, textual data, this is hard stuff to understand. So how are we going to process it? Well, the way that we traditionally have processed textual data is to try to process it manually, to try to read things and have people build spreadsheets and do all kinds of strange gyrations. And that's That's how we have tried to process textual data. However, as we're going to see, processing textual data manually is a really bad idea. Why is it a bad idea? Well, number one, it's expensive. Number two, it's error prone. Number three, it's not scalable. There's a lot of good reasons why doing manual processing of text is not a long-term viable proposition. Again, why? Because it's expensive, it's error prone, people get tired, people have to go to the restroom, people have to go to vacation, people get sick. People are frail human beings. It's not scalable. So this is what happens when you try to have a manual proposition of processing your textual data. It is not a good long-term solution. So if we're serious about starting to use text in decision making, we need to put text into a database. Why? Because the computer doesn't need to take vacations. The computer doesn't complain about salaries and raises. That the computer does not have many of the problems that we get with trying to manage human beings. However, when it comes to looking at and managing text, trying to take text and put it into a standard database system is like the proverbial trying to put a square peg in a round hole. And you can take a square peg and you can put it in a round hole, but it's a very uncomfortable, awkward fit. It just doesn't work very well. So we've got a problem here. On the one hand, we need to get our text onto a database. On the other hand, database management systems are not very amenable to having the text put into them. So let's take a look over time at how the computer profession has tried to look at handling text in technology. In the very beginning, there were something called comments sections. A comment section is something that a computer programmer would put into a COBOL format and say, this is a comment, and people can put in here whatever they want to. The problem with comment section is that the data that people put in there was very irregular. Some people put in a whole lot of data. Some people put in very little or no data at all. So comment sections were the first thing that appeared in our world to try to handle text. The database vendors recognized the problems with comments, and soon there was another data type called a blob. And with a blob, we could handle variable length data, and we solved that problem. However, it turns out that just because you can put text into a blob doesn't mean that you can do anything with it. And so pretty soon, we found some technology called SoundX and stimming. And SoundX and stimming were an approach to trying to cope with text. And the problem with SoundX and stimming is they really only addressed a small part of the problem of dealing with text. After we had SoundX and stimming, we then had something called tagging. And tagging was really the first commercial approach to doing anything with text. The problem with tagging is that with tagging, you've got to know what you're looking for before you go into your document. And so tagging was definitely a step forward, but it still had a lot left to be desired. After tagging, we had something called NLP, natural language processing, along with taxonomies and machine learning. And that's where a lot of people are today. And NLP is definitely a step in the right direction, but it doesn't go far enough. There are some major drawbacks to NLP and machine learning. And then today, at the end of the evolution, is something called textual ETL. I'm going to talk with you today about textual ETL so you can get a feel for it. So this then is the progression that has been made in our industry from the very early days to today in terms of dealing with text. So what is the difference between NLP and textual ETL? There's a lot of differences, but the number one difference is context, is that textual ETL looks at both text and context, whereas NLP looks at just text itself. And so the little expression that we use, NLP tells you what your customer is thinking. Textual ETL tells you why your customer is thinking about that. So what do we mean? What do you mean by what? What might mean your girlfriend is mad at you, and why you have bad breath. So that's the difference between what and why. Now, when you get into it, there's a lot of other differences between textual ETL and NLP. But the essential main difference is NLP tells you what's going on. Textual ETL tells you both what and why. Okay, here we have raw text being fed into textual ETL. And when we do that, now we can fit text comfortably and easily into a database. And what do you typically have in there after you've done disambiguation? By the way, another word for textual ETL is textual disambiguation. I got tired after a while of saying disambiguation because that's a long word. It's much more convenient to simply say textual ETL. But in fact, they are the same thing. So suppose you say, okay, Bill, thanks for telling me that you now can put text into the form of a database. Thanks for telling me that. So what? Now you can go to management and sell them a database. The problem is no one wants to buy a database. There are people on this earth, management, you show them a database and they run as far and as fast as they can. What does management want to see? Management wants to see visualization. Management doesn't have time to dig through the databases and the information that's there. So it turns out that once you put your text into the form of a database, the visualizations are actually easy to create. So you say, okay, Bill, thanks for telling me all this. This sounds like a great theory. I'm here today to tell you this is not a theory. This is something that is being done today, And this is where the world is at. Now, before I go any further, I'd like to mention that we do have a class that can be taken over the internet. It's for free. The next class will start up in the month of July. It takes 2 weeks to take the class, an hour a day. So far, we've had people from 47 countries take the class. So if you're interested, the easiest way to find out about it is to simply contact me on LinkedIn. So I'd like to tell you, if you'd like to find out more about textual ETL, again, the cost of the class, it's for free. We don't charge anything for it. So let's take an example of what textual ETL and being able to do text analytics looks like, because this is something that people are doing right now. So anyway, let's go to a restaurant. So here we see restaurants. Now, restaurants are kind of interesting places because they're very sensitive to the satisfaction of their customer. If customers start to become dissatisfied with restaurants, the restaurant loses money and is soon out of business. So if anybody really cares what the customer is saying, it has to be restaurants. So we went to this one restaurant chain in the United States. I don't believe they're in India, but I don't know. Maybe they are. I don't think they are. And we went to this restaurant chain, and they were getting customer feedback on the table of the restaurant. When you came to eat at the restaurant, they had a little card, and the card said, if you give us feedback, we will give you $5 off your next eating experience at the restaurant. And so in a month's time, they would get around 50,000 people send in their information. So, and by the way, I just picked this particular feedback out randomly. The people said all kinds of things. They said good things. They said bad things. They said all kinds of things. But as an example of the kind of feedback that people were giving the restaurant, and I'm going to read this for us. Product: Caesar salad, Parmesan chicken breast. I have ordered a Caesar salad with Parmesan chicken breast twice now. Both times the restaurant neglected to include the chicken in my to-go order. Also today, I was given dressing that had separated. I called and was told that that's just how it was going to be. I love your restaurant and was very disappointed. Not a good experience at all. So this is the kind of feedback the restaurant would get on a monthly basis. So we went to the top management of this restaurant chain, and we asked them, are you listening to your customer? And they said, oh yes, we're listening to our customer. And I said, oh, okay, how do you do that? What does that mean? And what the gentleman said was as well, at the end of the month, we print off all of these comments, and we put them on a big listing, and it goes to this one vice president's desk. And so we went to this vice president, and we said to the vice president, and once you get this listing, what do you do with it? And he looked at us and said, Bill, we can't do anything with it. There's 50,000 of these comments. We don't have the time to sit here and read this information. So what did they do with it? They threw it away. That's what they did with it. And so we said to them, wait a minute, we have something called textual ETL. We can do something with it. How would you like to give us a month's worth of your feedback? And so they said yes, that they would do that. So we took the comments that were there, and note that, let me back up here, note that the comments are in the form of text. In order to do analysis on this text, you've got to take the text and turn it into a database. So we did that. We took textual ETL, we read the text, and we created a database. And from that database, we created a visualization that looks like this. Now, the first thing that we did was we divided the comments up into sections. Some of the comments were about people, some were about place, some were about price, process, product, promotion, and so forth. So the first thing we did was we divided the comments up into different categories. The second thing we did was we identified whether or not the comment was negative, positive, neutral, or something else. And so this is what we came up with. We came up with a chart that looked like something like this. This was the number of comments that we had and what people were saying. Now, it turns out there's a lot of really valuable information here. And I don't have the time today to go into that information. But I'd like to point out two things in particular. Notice that when it came to price, nobody said anything. And so that's kind of interesting because that sends a message to management that they're not charging enough money. That if they went to their menu and raised the price a nickel or a dime or a quarter of the items on the menu, the restaurant would be making more money and people would still be happy. And so is that an important message? You better believe that that is an important message. And the same thing goes for promotions. This particular restaurant chain was doing promotions, and they actually spent a lot of money and a lot of energy in promotions, but nobody ever said anything. Nobody ever said anything good. Nobody ever said anything bad about promotions. So what does that say about promotions? They might as well not be doing any promotions at all. So from a standpoint of listening to what your customer is saying, being able to take text and turn text into important business decisions, this is something that came out. And again, there was a lot of other important information that came out. So this then is an example of how you can turn text and data science into business value, because this is the kind of thing that management needs to hear and has to hear. So now, by the way, we've got a lot of other really interesting stories about how you can turn text into important business decisions. But I thought that this one was very pointed and very direct. So who needs to start to be looking at text? And who needs to start to use data science? And again, when the data scientist turns into a worker in the corporation, I hate to tell you this, you go from being a data scientist to a data garbage person. And and when it comes to textual information, there is technology today that allows you to not become that garbage person. And who needs this kind of information? Well, the answer is everybody needs this information. Restaurants, hotels, banks, telephone companies, doctors, hospitals, pharmaceuticals, airlines, government agencies, manufacturers, and if there's anybody else that's missed, I'm sorry, but every person out there in the world needs this kind of information. So I hope then that this has been something that you find to be of use and of interest, and I hope that this, I don't want this message that I'm giving tonight to discourage you from data science. I really don't. I want to encourage you to go forward with data science. But I also want you to understand that there's this other element that you've got to understand. It's like an engineer. You show me an engineer that can design something, that's great. But engineering has got to know strength of materials and things like that as well. So anyway, I want to wish you a good evening. Well, I guess it's the daytime there, a good day today. And I hope you have a good conference. And I hope you find, this presentation. I'll be sending this presentation to the people at the conference. If you want a copy of this presentation, I'm more than happy to share it with you. Thank you so much, and we'll talk to you later.
Thank you very much for that, Bill. If anybody has any questions, quickly go ahead, and Bill will be happy to answer the questions.
Hello. Hello,
Hello?
I'm Aniket, sir. You described that textual disambiguation thing. So you took that review about that restaurant and you basically did some analysis on that. So I have a question that how that textual disambiguation thing is different from those NLP techniques like word to vec. So basically, they take those word embeddings and then they try to vectorize it and they use it for NLP purposes. So how does that textual disambiguation thing is different from the word to vec or other things that they use for NLP tasks?
There's a lot of differences, but the main difference is in understanding context. And I can tell you, having done this over the past 17 years of my life, context is much more difficult to understand than deal with text. Now, if you're really interested, we have a 2 week long class, an hour a day, and you're welcome to take the class. We'd love to have you, and and you will understand much more there. But the main reason is in terms of the focus on context as opposed to text.